So, hello guys, I guess we're live. So, we are doing, finding is it diagonalizable or not, and we are trying to find its diagonal matrix. So, I have done some part of it beforehand, like finding out the eigenvalues so that things can be shorter. By the way, you can do this in calculator. I try to do this in calculator because synthetic division is not my thing, but most conventionally we do it by synthetic division, but that's not my thing. So yeah, I had to rely on calculator. Sorry for that. And I also took out eigenvectors of lambda equal to 8, eigenvalue 8. So I did that because I have done it all years earlier, so I didn't want to waste your time on this. But now we will do for lambda equal to 2. Let's go for lambda equal to 2. And since the 2 comes 2 times, so we have to solve it by echelon form, like rank of matrix and stuff, we have to solve it like that. So because we have to later use it for AM and GM, which is algebraic multiplicity and geometric multiplicity. So yeah, we would have to use that. So we ain't doing that with Cramer's rule because this was a unique eigenvalue, so we did it with Cramer's rule. So yeah, in before lecture I made a mistake that middle one sign is minus already. I don't know if I did that mistake or not, but let's be on the safe side and repeat. I pointed out that mistake of mine, I guess so. So yeah. So this 2 is required in eigenvalue. So I have to avoid using Cramer's rule, and I have to use echelon form of finding rank of a matrix, so yeah, I have to do that to solve that equation. So for lambda equal to 2, first I have to make, so its formula is a minus lambda I equal to 0, no, into x. By the way, it's matrix, not determinant, I guess so. So x equal to 0. So x is x1, x2, x3. So yeah. Okay, we got x1. So we are trying for x2 and x3. So let's go. So new lambda a matrix is 6 minus 2, because we have to write the diagonal elements as minus lambda I mean minus eigenvalue. We have to do that with diagonal elements because I is a unitary matrix. Unitary matrix is everywhere 0, only diagonals, the elements are 1, 1, 1. So we are multiplying a scalar to this. So every element gets multiplied by scalar lambda. So lambda multiplies to every 0 and becomes 0. Only diagonal ones are getting multiplied with lambda. So when we are subtracting that, we subtract it from all corresponding elements from this element position. So lambda I getting since it is only lambda in the diagonals, so we in that corresponding position means also a matrix diagonal also we consider, and we subtract lambda from this a or the diagonal. So diagonal matrix of unitary matrix has lambda, which gets subtracted from diagonals of E matrix. So yeah, so this is how it looks. So first let's only write diagonals, since we will write only diagonals because to make it easy. So lambda is same 2, so 6 minus 2, 3 minus 2, 3 minus 2 again. Now we will write the other same part of the question which is there. Now this is our matrix. Now this is variable matrix. 3 unknowns are there, x2, x3. Then null matrix 0, 0, 0. I wanted to do this, in a short form, but that was my purpose. But it is a sort of hassle, so I thought let's go live. You know. Also, I think so. I didn't came live on this channel, so let's give a shot on it. So I guess my chat is on. Yeah, it is on. So yeah. Let's go ahead. 6 minus 2 is 4. Minus 2. 2. Minus 2. 3 minus 2 is 1. Minus 1. 2. Minus 1. 3 minus 2 is 1. Mm, so you're also not only because these two are same eigenvalue, so I'm doing that echelon form. I can give you another reason. So this is much more important reason I would give you now. So listen to me carefully, okay? So yeah, now I'm gonna give you the important reason. So let me divide this number by, wait a second, let me divide this number by 2. So this is gonna be 2, this is gonna be minus 1, and this is gonna be 1. So it does look similar, you know. This is same, and if I multiply this by minus sign, then it becomes 2 minus 1 and plus 1. It's same, and if by using a common factor or something, rows come similar, you can't use the Cramer's rule. So you can't definitely use Cramer's rule, so I have to go by this. 2 minus 1, 1, okay. Oh, sorry, where I was. Okay, oh, sorry. It looks a little shabby, but just it's alright. 6 minus 2 is 4, minus 2, 2 minus 2, 3 minus 2 is 1, minus 1, 2 minus 1, and 3 minus 2 is 1. So, in echelon form, we reduce a scalar from some rows, or we take multiple of some row and subtract it or do addition with some row corresponding elements, and we try to bring most of the areas where we can bring 0, and we find rank by taking number of unknowns, 3 unknowns, 3 variables, minus rank, which is non-zero rows. The rows which are not the rows which are means non-zero, like which has a non-zero element, rows which have a non-zero element. So if we reduce that, then it comes geometric multiplicity. Let me show you. Gm is equal to n minus r, which is, this is number of knowns, and this is rank, non-zero stuff, non-zero rows. So where the elements are not all 0, and am is algebraic multiplicity. How many times lambda repeated? Wait a second, sorry. Lambda repeat, how many times? So here our same lambda 2 is repeated 2 times. So what would be its an? It would be 2. Okay, and if am is equal to gm, then it's called diagonalizable. You get it, I guess. So whatever the spelling is, I'm not getting into that. Yeah, you got the point, right? You got the point. So where are we? Yeah. So let's go with the row operations. Since these are the same, just multiply by 2. So I'm gonna do R3. So what we can make 0, we can make these 2 0, I guess. So maybe these 2 0. I guess I can make these 2 0. So yeah, let's go. So I'm gonna do R3 minus R1 minus 2R3. So R1 on the left side is gonna get reduced. So this R1 will change. R3 will remain as it is, and then I'm gonna do, since it is only the if we multiply -1 with this would come. Then we would do R2 minus uh, R2 minus R1. Yeah. Sorry, R2 minus R3. Then R2 will change. R3 will remain as it is. So let's go. Let's try this. So R3. No. Sorry for my confusion. For real. R1 minus 2. This writing. Oh my god. My writing is really weird. R1 minus 2 R3. Then I guess, wait a second. Then R1. No, R2 minus R3. Then what do we get? So by this we get these both 0. First two rows are 0 because 2 into 2, 4 gone. Right. Wait a second. Am I doing it right? Am I doing it right? Wait a second. Oh, no. R2 plus R3. Come on, they are opposite signs. So to reduce them, I have to just add them. Because they are already in opposite signs. So they are going to subtract. So since this is opposite to this, if I add it, plus 2 minus 2, 0. 1 minus 1, 0. Minus 1 plus 1, 0. 4. And when I do R1 minus 2, R3, then 4 minus 2 into 2, 4, 0, minus 2 minus 2 into 1 equal to what? Wait a second, for real? What? 2R3, right? 4 minus 2 to the 4, 0, minus 2, minus 2 into 1, minus becomes plus, minus into minus is always plus, okay? Minus signs multiplied with minus sign is plus sign. So minus 1 into 2 is minus 2, then that minus 2 would get minused from minus 2, then those 2 minus gets multiplied and becomes plus 2. Let me show you, okay? This minus 2, then this, since we are doing this should be already minus. Now we have this into 2, so minus becomes plus. 2 into 1 is 2, then minus 2 plus 2 is equal to 0, and we are done with it. So yeah, that's how it goes. Yeah. So then 2 minus 2 into 1 is 2, 2 minus 2 is 0. And now it's hero time. Now it's hero time. So yeah, 0, 0, 0, 0, 0, 0, minus 2, minus 1, minus 1, no, sorry, plus 1, and we're done with it. Let's go. Now, let's do it. And we're done with it. And 0, 0, 0. Now, if we multiply that, into x1 minus x2, plus x3 equal to 0. It gets multiplied here. So, since only one equation is there, 3 unknowns are there, then we have to take a parameter. Parameter is like we take a thing that we compare to something, then we get a variable that can be assumed closest to the thing, closest to the root. So, how many unknowns, how many parameters do you have to assume? That comes when you take how many variables are there. Three unknowns. How many equations are there? We have one equation, so we have to assume two parameters. So two parameters. Parameters are values that we assume, variables that we assume, which are extra, and which two parameters we are gonna write, uh, in relation or in comparison to x, and we are gonna try to find the value. You will see how it is. S T. Let's take it S and T. Okay. I guess you got this part clear. Then you take 2x1 minus s. No. Wait a second. Nah, bro. Wait a second. 2x1, x2 plus x3, x3 is equal to 0. Let's take s. Okay. 2x1 minus s plus t equal to 0. So, t is equal to s minus 2x1. Let me show how it is. 2x1 goes on other side, sign change, minus 2x1. Because here we are getting 2x1, there is in depth of 2x1. Okay. So, minus s, change the sign, plus s. So, s plus s minus 2x1. Okay. And minus s is equal to, same logic, t goes there, minus t, 2x goes, 2x1 goes, minus 2x1. Since here is minus and we want plus sign to make it our equation calculation convenient, so we would multiply whole equation by plus. So since this is a common multiplication on left hand side and right hand side, it is equal, it is same, it is balanced. So we can do that. So let's multiply by minus 1. This minus cancels, and this becomes plus. Let's erase this, and we got s equal to t plus 2x1. But is this right? No. Let's go. Let's see what's ahead. So we have what we have. What do we have, bro? Okay. So wait a second. So x equal to, you take this should be 2x1. X1 will be, wait a second. X1 will be s minus t by 2. But do you have to take that? I don't know. I totally don't know. Wait a second. S minus t by 2. Okay. S minus t by 2. Now this would be do in x1. So this would be for a second.